It's.
Hey, I spelled your name right.
I appreciate that.
I didn't want to make you mad because it's a Friday.
That's true. It's true. Show me your pin.
Okay, so I had a student get me this pin, and it says, me, sarcastic, never. I'm never sarcastic. I don't know what the problem is.
I don't know why.
I don't get it.
Anyways, let's talk about velocity versus time graphs. We're trying to stay focused.
We're going to get focused today.
Okay.
We got this.
So what we're going to talk about today is, previously we've talked about motion maps. We've talked about position versus time graphs. Those are two different ways to show how the same object is moving. All right. So now here's another one. So this is like number 3. So how to use the velocity versus time graph to show how those objects moves. What we want to do is use this to describe what's called acceleration. So we're going to introduce something new.
Acceleration.
And what we're going to know we get this when we can take that graph and be able to explain things, or go vice versa and take the motion and be able to make a velocity versus time graph for it.
Okay, that sounds really good, but I just need to go over one quick thing. Mm-hmm. So a lot of students have this misconception for this distance versus time graph up here, where if something starts away from the origin and it's working its way towards it, and it's walking towards it, whether it's a fast constant pace or slow constant pace, they start away from it and then they go like that.
Oh.
That's not how that works.
No.
Because that just means it magically showed up in the thin air. Poof! And then it starts going away.
And then it starts going
But it's
away.
not going away from it. It's going away from it. Or it's going... I want them to go towards it. So it starts away...
So at time equals zero, it's starting
away from it, and they want to walk towards...
And they're moving towards
the
zero.
The origin. Well, think about it as this. You get out of your car, and let's say the house is your origin. Okay, you get out of your car, and you walk towards your house, so you're getting closer and closer to the origin. So you're starting away from it, but you're moving towards it.
Gotcha. Okay, that's
Hopefully
good.
That's a little bit better for us to understand that. So here's our first example, guys. So notice, make sure we have velocity on this side, time at the bottom, and then this is just a matter of graphing our points. So we have 0, 0 down here. We have 1, 2. Let's go 1, 2. We'll go every second one down here on the bottom. And then we'll just go by ones. So we go 4, 6, 8, and 10. So then we have 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10.
Okay, so I'm looking at this and I'm thinking
this
back.
This looks really familiar.
It looks very familiar to what we did with the position versus time graph. So that means it must be traveling at a constant speed because it's going the same, because it's a straight line.
That would be correct if that was distance, but it's not distance, Mr. Spencer. We really have to pay attention because this is talking about velocity versus time, not distance versus time. So if it was position, then this would be a fast or a constant rate of speed. But that's not what's going on. We're talking about the velocity is increasing. So imagine you get in your car and you step on the gas pedal. Your distance is speeding away from where you started at, but your speed is just going up at the same rate every single time.
So at 0 seconds, I'm not moving, but after 1 second, I'm going. The speedometer is at
2 meters per
2
second.
seconds,
and then at 4 meters per second, or
so
2 miles per
faster.
hour. We're getting faster. So this is our acceleration. So you are accelerating in this graph.
Speeding up.
So again, if we talk about our slope from math class, we have our rise over our run. Okay, and then if we do our rise here, well, our rise is in velocity. So that is meters per second. Okay, and our x-axis is just time. So which gets us an acceleration of meters per second
every
second. So we're increasing a meter per second every single second.
So that's good. So that's something new that we've talked about. But I think the most important thing here, besides the idea that the slope of a velocity versus time graph is acceleration, is also you got to be careful to make sure what kind of graph you're looking at.
Yes.
Because what happens on a position versus time graph
is different than what's going on in a velocity versus time graph.
Sounds good. Let's do this thing.
We got this.
Okay. Okay, so
I think this is almost exactly the same. And if we just do 1, 2, 3, 4, and 5, we can easily just go up here and we go by 2s again. Well, we might not be able to go by 2s. It might go off. It goes off.
Okay.
It's gonna go off the charts. Yeah, I'm sorry, Mr. Spencer. We just got to deal with it. And then we got like 15, like way up here at the top somewhere. So 15's way up there. We got 1, 3, 2, 6. 3, 9, 4, 12. I think I put something in the wrong spot there. 3, 9. There we go. 4, 12. So if we do this is the exact same as the previous graph that we had. It's just a little bit steeper. We have a steeper slope, so that means it's accelerating at a faster rate of speed.
It's kind of like the difference between a Civic and an Audi R8.
That is a fun car to drive, by the way. It is. I actually drove one. It's a lot of fun. Moving on. Nice. Not that we'd ever get sidetracked. Oh, I know what's going on here, Mr. Spencer. I totally know.
We've seen this before.
This is just going to be a straight line going across, which means
they're not moving.
It's not moving. Wait.
No, that was position versus time.
Ah, dang it.
So
this is velocity. We got velocity. So this means it's not. It's moving.
It's moving.
But it's just staying at a constant rate of speed.
Oh,
and
that's
Matt,
interesting.
do you ever use this thing? And I'm sure nobody in the world knows how to use these. Cruise control.
Cruise control. Heck yeah, because like when we have to drive a long way and like all my kids are fighting in the back, and I don't want to like road rage or anything like that. You put on the you
if
put on the
only
cruise
more
control.
people knew how to use that. I love it when you get behind somebody and you go to pass them, and then they speed up with you, and then you get and then
it's a race. I may do that often.
I win usually. Moving on.
So, but wait. So go back, if you can. Okay. So I think the important thing is that when we on a velocity versus time graph, when we see that horizontal line, that means it's going at a constant speed. Like it's just when we see that on a position versus time graph, that's when you get the straight. You get the straight line pointed up.
And that means you're just staying still. Oh my gosh, it just got dark in here. The ghosts showed up. We are freaking out. It's okay. We're good. I don't want to die.
Okay. Oh.
Uh-oh.
Okay, let's plot this and let's see what's...
Plot it. So we're at...
0.4. So at 0 seconds, we're traveling at 4 meters per second.
Okay.
At 1 second, we're going 6 meters per second.
Okay.
At 2 seconds, we're going 8 meters per second.
This seems nice.
Still going at 8 meters per second after 3 seconds.
3 seconds. Gotcha.
All right, and then we go to 2 seconds.
Ah!
So slowing down. And then 0 seconds.
I mean 2 meters?
At 2 No. See?
At 4 seconds,
4 seconds we're going 2 meters per second.
That's when you confused me. It doesn't take
Just
much.
gotta listen.
I don't like to.
Okay.
Kind of like our students sometimes. Anyway, I
not
said
sarcastic ever.
Never sarcastic. Okay, focus. All right, so what's going on here?
So I'm looking at this. So we've got some different things going on here.
We are talking about velocity versus time versus position.
So when we start off, it looks like
we're already going. We're already at 4 meters per second, so we're already moving.
You're right.
So it looks like for 2 seconds we are increasing speed, right?
So it's going up 2 meters per second every second, and then after
increasing our speed is accelerating. So we are accelerating at 2 meters per second every single second.
And then for a smidge, we're just cruising along. Hit the cruise control
for a second, because
it's just how it works.
That's how it works.
And then Bambi pops out in front of us and slam on the brakes.
So decrease. So So if we're decreasing our speed, we're not accelerating. We're still accelerating,
It's just
but
negative.
it's a negative acceleration. So that's like you said, you're stopping on the brakes.
Mm-hmm.
You tried to kill Bambi, didn't you?
It got out of the way.
Got out of the way. Okay. Okay, so we decrease our speed at a very fast, constant rate for at least 1 second, because we go from 8 all the way down to 2, and then we go from 2 to 0. So that's when we are at a complete
Stop.
We are at a
Because
complete
velocity
stop.
is
It's
0.
because our velocity is 0. It doesn't mean we're going away from our origin. It just means we have come to a stop at that point. I like it.
Okay.
All right, so now what we're going to do is we're just going to take a look at this and describe what's going on, okay? So if we're looking at this first little bit,
You know what, Mr. Conrad? So while you're doing that, I think one of the, like, whenever I have these, one of the things that I like to do is break it up into chunks. So we've got, like, a chunk there from, like, 0 to 4 meters per second, from 4 to 8, from 8 to 10, 10 to 14 seconds, and 14 to 16 seconds, and then from 16 to 18 seconds. So I think
There's a lot going on here.
There's a lot going on, but if we take it by chunks, it'll be a little
makes
less.
life a little bit
yeah.
easier for us. For that first part I did in blue, it's definitely just increasing its speed. So we are accelerating during that time because,
Right.
again, this is a velocity versus time graph.
Velocity's going
So it's-
up during
so
that
velocity. What's going on? What do we get? If it's a horizontal and we're dealing with velocity versus time graphs, that means we are going
time.
at
The velocity's staying the same, so it's going at a constant speed.
okay,
And then
then
we speed up again from 6 to 10 seconds. So this is kind of like.
yep, keep
Wait,
going.
wait. Like, if you hit the brakes, then you go for it. You're like.
Moving on. I never want to
And
drive
then
with you ever again.
It's just the Nissan works that way. Anyways,
That's
back
the
to the
operator.
important stuff.
Okay, then we go on
Constant.
another straight line, except I think I had like a little heartbeat in there.
Yeah,
Then it looks like we come down for this last little
so that
bit.
means
So that,
slowing down,
Okay.
not running down a hill or something like
yes,
that.
very good. We are not running downhill. We're talking about velocity, so that just means we're slowing down. And then again, here at the end, we are going at a
Constant speed.
constant speed. I think we got it.
I think we stayed on track, kind of.
For the most
today.
part. Let's do 2 more.
Okay.
Look, I have example 6, we have example 7, and we really need to take a look at example 7.
Okay.
So again, I didn't mean to cross that out.
Velocity.
Velocity versus time graph. That's the first thing I do when I look at my graphs, is I want
Know
to
what you're
notice
doing.
what I am using. Am I using velocity versus time or position versus time? So again, this first little bit here, this is going to be our constant speed, and then
We speed up,
speed up,
and then we're going at a faster constant speed.
and then we were going at a very good, faster constant speed. So if you wanted to, guys, you could do 1, 2, 3, because we're breaking it up in chunks. So at 1, we are going at constant speed. 2, we are speeding up, and 3, we are just going at a faster constant speed.
All right.
Okay. Now, if we had them draw these, it'd be the same thing. If we're starting and I give them a data table, or even if I
yeah.
don't give them a data table, they would just have to say, okay, if we're going at a constant speed and we're already traveling, then we would just go, well, that would mean we're increasing speed. But if we're saying we're going the same speed, then we'll just lie a line straight
Right.
across. All right, let's take a look at this last example. Okay, so a lot of us, we're going to say, hell, we are traveling at a constant speed, right, Mr. Spencer? Okay,
Oh.
we're traveling at we're traveling at a constant speed, and then we move towards the origin at then we slow, and then we slow down, right?
Hey, yeah, I'm noticing
Maybe that's just how we
something.
do it. I mean, that's what we did on all the other ones. Oh crap!
That's not a velocity versus time graph.
What was the first thing that I always said I usually do, Mr. Spencer?
Look at the axes, see how.
And what did I not do this time?
You didn't look at the axes.
I didn't pay attention. I was a dunderfart. Okay, so guys, you really do have to pay attention to what that y-axis is. If you pay attention to that, if you see position, then you need to be thinking distance. and something moving at a constant rate of speed, and that's what you're going to have with this diagonal coming down. Okay.
So we
It's
go
not
back to
slowing
this,
down.
right? We go back to this idea of breaking it up into chunks. So on a position versus time graph,
So for this, we'll label this 1 and 2.
Uh-huh.
So for number 1, this is stopped.
it's not moving. It's just sitting there somewhere in a positive
Distance away
distance
from
away
our
from
origin.
yeah.
So imagine like you're at the stoplight and you're going to your house.
Right.
Okay, you're at a stop,
So
and then
they're
you're
waiting.
moving towards your house. So this is home, and then you are some distance away from home, and you're just standing there.
Yep.
And then number 2, you're not decelerating. You're just moving at a constant
Speed back towards the house because this is a position versus time graph and not
constant
a velocity.
speed toward
Yep.
the origin.
Or negative. Either way works.
Okay. Again, if you're moving towards the origin, doesn't mean you're going like this. That means you're going back in time. If you build a time machine, can I borrow it?
You know what? I'll work on that. I'll let you know.
Okay.
I'll let you know how that goes.
All right, guys. So just in all honesty, though, please be aware of usually this bottom part is time for
Right.
both of our graphs, but you really have to pay attention to what is on that y-axis. If it's position versus time, you got to be thinking constant speed and not moving. If it's velocity versus time, you have to think of it's speeding up or it's slowing down versus. So that's the main difference between them.
Sounds good.
All right, there you go, guys.
All right. Let us know if we can help.